All right, so we've got some really cool stuff to dig into today. It's all about Mercury, and you guys send in some articles about BepiColombo's sixth flyby,
Oh, yeah.
which, if you remember, it's that ESA JAKK joint mission.
Right.
And get this, this is the last flyby before it actually goes into orbit around Mercury in 2026.
That's right. Yeah.
And the images that are coming back from it are just mind-blowing. I mean,
Yeah,
seriously, it's like we're getting this sneak peek into, like, all the hidden stories that this planet has to tell.
And it's not just about, taking pretty pictures.
Right.
Each of these flybys, it's actually adjusting its course. Like it's getting these little gravity boosts
Oh,
to put it on the right track for when it gets there in a few years.
so it's like it's working while it's sightseeing?
Absolutely. Yeah. Gathering all this data, laying the groundwork for the main mission.
Okay, so there's this one image that just totally grabbed me, and it was this incredible shot of Mercury's North Pole.
Wow.
And BepiColombo actually took this picture while it was flying through Mercury's shadow. You can actually see the Terminator line there. You know, that really sharp divide between, like, day and night on the planet.
Right.
And get this, there are these craters up there that are just always in darkness.
Yeah. Permanently shadowed craters. Crazy, right?
Yeah, it's wild.
And you know what's even crazier?
About that.
Those are some of the coldest places in the whole solar system.
Really?
Isn't that wild, especially considering how close Mercury is to the sun?
I know, it just seems counterintuitive, right? But that's what's so fascinating about this. Like, the things that we think we know get totally flipped on their head when we start looking at places like Mercury.
Exactly.
And what's even more interesting is that, like, scientists think there could be frozen water in those craters.
Right. Isn't that crazy?
Ice on a planet that's basically hugging the sun.
Okay.
I never would have thought.
It really makes you rethink, like, where we think water can exist in the solar system,
Absolutely.
Like, we're so used to, thinking about Mars or the moons of Jupiter and Saturn. But to find water ice on Mercury, that would just be, it would be huge.
And what would that even mean for, like, our understanding of where else we should be looking for life in the universe,
Exactly.
That's such a good point.
If we find it there, who
Right.
knows where else it could be hiding?
Okay, so shifting gears a bit, another feature that really jumped out at me was the Borealis Planitia.
Okay.
It's in the northern hemisphere, and it's these vast plains that, I mean, they just look like they were, like, sculpted by volcanoes a long time ago.
Oh, yeah, billions of years ago.
Wow.
Imagine, like, massive lava flows just erupting and spreading out.
Really?
Yeah, this had been around 3.7 billion years ago.
Wow.
These lava flows, they just flooded over everything,
Wow.
Existing craters like Henri and Lismore, they were just completely buried.
Oh, wow.
And what we see now, those are the remnants, These kind of wrinkled plains, almost like they've got these scars all over them.
It's amazing to think about the scale of all of that, like the sheer power of those eruptions.
It's mind-boggling, right? And that texture, those wrinkles you mentioned,
Yeah.
that's actually from Mercury shrinking as it cooled over billions of years.
So it's basically like the planet, like, scrunching up as it got older.
Yeah, you could say that. Like planetary wrinkles,
Wow. Okay, well, speaking of dramatic features,
Yeah.
we can't forget about the Caloris Basin, right?
Oh, absolutely.
I mean, this impact crater is over 1,500 kilometers across.
It's massive.
So it just dwarfs everything else on Mercury, and it's just this stark reminder that this planet has had a pretty violent past.
Imagine the impact that carved that basin.
I can't even begin to fathom.
Like, the shockwaves would have rippled across the entire planet.
Wow.
And you can still see the scars, like, all these troughs radiating out from the center.
Yeah.
And there's this really interesting feature. It's this bright lava flow that seems to be connected to this deep trough near the basin. And scientists are trying to figure out, did the lava flow into the Caloris Basin after the impact, or did it flow out?
Another mystery for BepiColombo to solve.
Exactly.
I have a question.
Yeah, go ahead.
So for a planet that's so close to the sun, you'd think Mercury would be, like, super
I
bright.
think so, right.
But the images actually show it's kind of surprisingly dark.
Yeah, it's a bit of a contradiction, isn't it?
So why is that?
So basically, over time, Mercury's surface actually gets darker.
Oh, interesting.
It's all because of that harsh space environment, all that solar radiation.
Oh, okay.
Think of it like, when the paint on a house starts to fade in the sun.
Oh, I see.
It's kind of like that.
So it's like getting bleached by the sun.
Yeah, you could say that. And newer features, like if there's a fresh impact crater or a new volcanic deposit, that stuff looks brighter because
Yeah.
it's exposing material from below the surface, stuff that hasn't been cooked by the sun for billions of years.
Oh, that makes sense.
So basically, the darker it is, the older it is.
Wow, so those bright patches we see, those are kind of like fresh wounds on the surface of the planet. And eventually, they'll darken too, right?
Exactly.
That's fascinating. It makes features like Nether Faculae even more interesting.
Tell me about it.
I mean, this is like this bright patch that shows where Mercury's largest volcanic explosion happened, and you can even see the volcanic vent at the center of it.
It's like a window into the planet's violent past.
Exactly. And then there's the Fontaine crater, which is another one of those bright spots.
Yep, that one's pretty young, only about 300 million years old.
Oh, wow. A spring chicken.
And you can still see all the bright debris surrounding it from when it formed. Really cool stuff.
So by studying the composition of these dark and bright areas, like BepiColombo is going to give us this much better understanding of how Mercury's crust has evolved over time.
Absolutely.
It's almost like having a time machine, right?
It really is, like watching the planet age before our very eyes.
But, there's one big question that I still have.
Yeah.
What exactly is Mercury made of?
That's the million-dollar question.
I know, right?
We know it's a rocky planet, obviously, and we know it's got this huge iron core.
Right.
But the exact makeup,
Yeah.
what are the specific elements in its crust and mantle?
Right.
That's still a bit of a mystery.
Huh.
And that's where BepiColombo comes in.
Okay.
It's going to be analyzing both those old dark areas and the newer, brighter stuff.
Right?
And that should give us some clues about how the planet formed, and how it relates to the other inner planets.
So each flyby, it's not just about snapping these cool pictures.
Oh, absolutely not.
It's about gathering the data that's going to revolutionize our understanding of this entire planet.
Precisely. Each flyby is like another piece of the puzzle.
And the sixth one was extra special, right?
Oh, yeah, it was.
I mean, this was actually part of a back-to-back flyby campaign.
The first time they've ever done that.
Oh, wow. Back-to-back flybys? That must have given them so much data to work with.
It's a data feast.
That's incredible.
And by studying Mercury from all these different angles, in such quick succession.
They're getting this really unique snapshot of the planet's environment, and they can compare the data from both flybys to see what's changed in between.
Oh, that's brilliant. I can only imagine how excited the scientists must be, analyzing all this new information.
It's like getting a mountain of presents right before your birthday.
I love that analogy. And then the real party starts when BepiColombo actually settles into orbit in 2026.
It's going to be epic, like the main course after a delicious appetizer,
Speaking of appetizers, I'm suddenly feeling a bit hungry for some more space knowledge,
Oh, are you thinking what I'm thinking?
I think I am. It's time for a little shout out to our friends over at SpaceInfo Club.
Of course. I knew it.
I mean, their website and social media are just packed with incredible information about space.
It's like a one-stop shop for all your space cravings.
Exactly. They've got news, articles, even courses about everything from black holes to the search for extraterrestrial life.
And they do such a great job of making it all accessible, even if you're not a rocket scientist.
Exactly. So whether you're a seasoned space buff or just starting to explore the cosmos, they've got something for you.
Seriously, if you love space, you need to check them out.
Absolutely. You can find their website at www.spaceinfo.club.
Easy to remember.
And don't forget to follow them on social media too, especially their Instagram at spaceinfo.club and their YouTube channel. They post amazing content all the time.
Yeah, they do.
But for now, let's get back to those incredible images of Mercury.
Oh, right.
And hey, if you want to see them for yourself, make sure to check out ESA's Planetary Science Archive.
They'll be publicly available soon.
I mean, those close-up views of Mercury's craters and plains and cliffs, they're just breathtaking,
It's truly awe-inspiring.
It really makes you realize just how much is out there that we still don't know.
So much to explore, right? And you know what blows my mind?
What's that?
Those images, those are just scratching the surface.
What do you mean?
Imagine what we're going to learn when BepiColombo starts collecting even more detailed data once it's actually in orbit.
Oh, I know, right?
Yeah.
We're just getting started.
Exactly. It's like we've just opened the first page of a brand new book.
And we have no idea what adventures are waiting for us.
Precisely. And personally, I'm really curious about Mercury's magnetic field.
Oh, yeah. Tell me about that.
It's super strong, especially for such a small planet.
Yeah.
And we don't really know why.
That's so interesting. And I mean, you've got this incredibly powerful magnetic field, but it's also, right next to the sun.
Yeah, right in the firing line.
So how does that affect, its environment? Does it have any protection from the solar wind, or is it just constantly bombarded with radiation?
Those are excellent questions, and that's exactly what BepiColombo is designed to investigate.
Oh, that's so cool.
It's going to be studying that interaction between Mercury's magnetic field and the solar wind, and that's going to give us a much better understanding of how these forces shape, the entire planet's environment.
It's just mind-blowing to think that we're on the verge of actually unraveling these mysteries.
I know, right? It's so exciting.
BepiColombo has already given us so much, and this final flyby, it's like this incredible taste of what's to come.
Like a sneak peek into the future of planetary exploration.
Exactly.
It's like we've just finished reading the first chapter of a really, really good book.
And we can't wait to see what happens next.
Oh, absolutely not. I'm hooked. It's true. And those flyby images, it really has me thinking.
Yeah.
We always focus on like the big obvious features of a planet, right?
Right.
But sometimes it's like those subtle details tell like the most interesting stories. Like take those wrinkles we mentioned on those planes. It's like a record of Mercury actually shrinking.
Oh, wow.
Over billions of years.
Like a cosmic time lapse.
Yeah.
Right.
Exactly.
Just captured on the surface of the planet.
And it makes you wonder, what else can we learn from like those really subtle details?
Yeah.
Like think about those bright streaks and patches we talked about.
Right.
They really stand out against that darker, older terrain, right?
Yeah, it's like beacons against a dark backdrop, right?
Exactly. And those are signs of like more recent geological activity, maybe from impacts that dug up fresh material or volcanic eruptions that spewed molten rock onto the surface. And by studying the composition of those, scientists can start to piece together a timeline of Mercury's like geologic history, right?
Right,
It's like
yeah.
they're reading this history book that's written in rock and dust.
That's incredible. So those seemingly random splotches, they're actually clues to the planet's evolution.
Precisely.
That's awesome.
And here's where it gets even more interesting. Remember how we talked about Mercury kind of having this split personality?
Right, yeah.
These ancient craters right next to smooth, younger-looking plains?
It's like the planet has like two faces, right?
Mhm.
One ancient and weathered, and the other one's like surprisingly youthful.
That contrast is key to understanding Mercury's evolution.
Mm-hmm.
And those smooth plains, they aren't necessarily young, in the sense of having formed recently. They probably formed billions of years ago, but they've been reshaped and smoothed over time.
So it's not just about how old a feature is, but how it's changed since it formed.
Exactly.
Yeah.
And those subtle wrinkles on the plains, those are evidence of the planet's surface adjusting to its shrinking interior.
Oh, wow.
It's like the slow-motion planetary facelift
Oh, I love that analogy.
happening over billions of years.
It just makes it so much easier to picture.
Yeah.
So by studying these subtle changes, we can learn about Mercury's internal activity, not just its surface features.
Absolutely.
Wow.
And this is where BepiColombo's instruments are really going to shine.
Oh, yeah.
They can analyze the composition of the surface, measure the planet's magnetic field, study its thin atmosphere.
Right.
It's like giving the planet a full medical checkup
That's a great analogy.
using like cutting-edge technology.
It's incredible how much we can learn without ever setting foot on the planet.
Right.
But speaking of which, what about Mercury's orbit?
Okay.
Because it's the closest planet to the sun, but it also has this like most eccentric orbit of all the planets.
It's a wild ride.
Does that affect its evolution at all?
That's a great question. And yeah, absolutely.
Yeah.
Because that eccentric orbit means that Mercury's distance from the sun, it varies a lot throughout its year.
Wow.
And that leads to these really extreme temperature swings on the surface,
Right.
which definitely plays a role in shaping the planet's geology.
So unlike Earth, where the seasons are pretty mild,
Yeah.
Mercury's experiencing like scorching heat when it's close to the sun and then like frigid cold when it's farther away.
Exactly. Those temperature extremes probably contribute to all the weathering and erosion that we see on the surface.
Right.
And they might even influence the planet's internal dynamics, but that's something we're still trying to figure out. Yeah.
Fascinating. It's like Mercury's orbit is like this key part of its personality.
You could say that.
It's shaping its entire evolution, and it just makes me think about how interconnected everything is in the solar system.
Oh, absolutely.
Even small differences in a planet's orbit can have a huge impact on its environment.
Exactly. And that's what makes studying planets like Mercury so valuable.
Yeah.
It helps us understand, like, the whole range of planetary processes that can occur,
Right.
not just in our solar system, but potentially on planets orbiting other stars as well.
It broadens our perspective.
It does. It really does.
Okay, let's go back to the water ice for a second, because that's something that I can't get over.
Yeah, it's pretty mind-blowing, right?
Ice on a planet that's basically baking in the sun's heat.
But remember those permanently shadowed craters we were talking about? Those act like cosmic refrigerators,
Right.
shielding that ice from the sun's direct rays.
It's like finding a patch of snow in the middle of the desert.
Exactly, but how could ice possibly survive in that environment, right?
Yeah, that's what I'm wondering.
It all comes down to like the unique geometry of those craters and Mercury's lack of a substantial atmosphere.
Okay.
Because those crater floors, they never see direct sunlight.
Right.
And without an atmosphere to trap heat, temperatures can get incredibly low.
So these craters are basically like cosmic cold traps.
Yeah, preserving that ice for billions of years.
It's a reminder that even in the most extreme environments, you can find these surprising pockets of stability.
And it makes you wonder, if water ice can survive on Mercury,
Yeah.
what does that tell us about the potential for finding water in other seemingly inhospitable places in the universe, right?
It's a great question. I mean, are scientists actively exploring that possibility?
Oh, absolutely.
Right.
The discovery of water ice on Mercury has really broadened our understanding of where water can exist. And it's fueled the search for water on other celestial bodies, even those that seem incredibly harsh.
So it's not just about finding water on Mercury.
No,
It's about expanding our understanding of where water can exist in the universe.
precisely. And that has big implications for the search for life beyond Earth as well.
Oh, how so?
We always think of life as needing liquid water. But finding water ice in these extreme environments, it suggests that life might be way more adaptable and resilient than we thought.
Wow, that's incredibly exciting. So in a way, by studying Mercury,
Yeah.
we're not just learning about this one planet.
Nope.
We're learning about the potential for life to exist in this whole range of environments that we never even thought possible.
Exactly.
That's amazing.
And that's what makes planetary science so compelling.
Yeah.
Every discovery opens up these new possibilities, and it challenges all our assumptions about the universe.
Right.
And missions like BepiColombo, they're at the forefront of all this.
Yeah.
They're pushing the boundaries of our knowledge.
Okay, so I got to ask,
Yeah.
what are you personally most excited to learn about as BepiColombo continues its mission?
Well, I'm really fascinated by Mercury's internal structure.
Okay.
We know it's got this surprisingly large iron core for its size,
Right.
and we're not really sure why that is.
Yeah, I mean, what could have caused it to have this massive core relative to, its overall size?
Yeah. Right. Well, one theory is that early in its history, Mercury might have been hit by something huge.
Oh.
And that impact, it could have stripped away like a large part of its outer layers,
Oh, wow.
leaving behind this like disproportionately large core.
So it's like someone took a bite out of the planet
Yeah, kind of like that.
and just left the core.
Yeah, but that's just one theory, of course.
Right.
And BepiColombo will help us test that and other ideas by studying the planet's gravity field and its magnetic field and the way seismic waves travel through its interior.
It's amazing that we can probe the deep interior of a planet from millions of kilometers away.
It's pretty incredible, right?
Yeah.
And the data we get, it's not only going to tell us about Mercury's history,
Right.
but it could also give us insights into how other terrestrial planets formed, including Earth.
That's a great point. So by studying Mercury, we're not just learning about this one kind of unusual planet.
No.
We're gaining insights into the processes that shaped, like, all the rocky planets in our solar system.
Yeah. Exactly. It's like looking back in time to understand our own origins.
I love that. So even though Mercury is this small, seemingly insignificant planet,
Yeah.
it's actually teaching us some really profound lessons about the universe and our own existence.
Yeah, it really is.
That's pretty cool.
And who knows what other surprises it has in store for us.
Right.
As BepiColombo continues its mission, one thing's for sure, we're in for an incredible journey of discovery.
It's easy to get, like, caught up in all the incredible science that BepiColombo's doing.
Right.
But we got to remember the human element here, too,
Yeah.
Like, it took some serious ingenuity to get this mission off the ground.
Absolutely. And the technology behind those images we keep talking about, it's just mind-blowing. I mean, think about it. BepiColombo is flying through space at these crazy speeds.
Right.
And it has to time its observations perfectly to get those close-up shots.
It's like trying to hit a bullseye on a dartboard while you're on a roller coaster.
That's insane.
Yeah.
The precision involved is just incredible.
And then they got to transmit all that data back to Earth across millions of kilometers.
It's a testament to the skill of the engineers who designed and built this spacecraft.
Totally. This isn't just a science mission.
Yeah.
It's a testament to, like, human ingenuity and what we can accomplish when we set our minds to something, especially when we work together.
And speaking of working together,
Yeah.
don't forget that BepiColombo is a joint mission between ESA and JAXA.
Right.
It's a fantastic example of what we can achieve through international collaboration and space exploration.
I love that.
It just proves that, when we pool our resources and expertise, we can do incredible things. And the knowledge we gain from these missions, it benefits everyone, not just one country.
Absolutely. It belongs to all of humanity.
Exactly. It's about expanding our understanding of the universe as a species.
And I remember when I saw those first images from BepiColombo.
Yeah.
I just got this overwhelming sense of awe and wonder,
It's humbling, isn't it? You see those images and it just puts everything into perspective.
Totally.
Our everyday problems suddenly seem so small.
Right.
Compared to the vastness and mystery of the cosmos.
Yeah, space exploration has this incredible power to remind us that there's so much more to life than what we experience here on Earth.
It really does. It encourages us to think bigger, be curious, keep exploring and asking questions.
That's a spirit we need now more than ever.
Couldn't agree more.
So as we wrap up our deep dive into BepiColombo's latest flyby,
Yeah.
I'm left with this feeling of, like, excitement and anticipation.
Oh, what do you mean?
This is just the beginning.
It is.
And there's so much more to come.
Oh, absolutely. We've only just scratched the surface of Mercury's secrets.
I can't wait to see what new mysteries BepiColombo unravels when it finally gets into orbit.
Right. And how will those discoveries change our understanding of the solar system and our place in it?
I guess we'll have to wait and find out.
That's the beauty of it all.
It is. The universe is full of surprises.
Always keep looking up and never stop exploring.
Couldn't said it better myself.